You've now had some experience looking at the properties of rings and creating proofs about rings. And what we're going to do now is look at how to make some new rings. In particular, we're going to construct new rings out of old rings that we already know. So first we're going to look for rings that are subsets of other rings that we know. We're going to see what happens when we add a new element to an existing ring and see what kind of rings we get out of that. We're going to look at Cartesian products, which is another way that we can create new rings. And finally, we're going to see how matrices can help us. Now, I want to mention before we get into the rest of the video that we're not going to be working out a lot of examples here. What I'm going to do is I'm going to introduce you to these topics, ask some of the important questions, and that should get you primed to be able to work on the in-class activities. All right, so first we're going to start with something relatively concrete. What happens if I have a ring S and that S is a subset of Z? How can I make a ring like that? Well, one thing we might do is just look at a single element that you want to have in the ring and then see what else happens after that. So for now, let's pretend that one of the elements in the ring is 3. So the question is, what other elements might we have in there? Well, let's look at some of the axioms, right? For one thing, we need closure under addition. If we have closure under addition, that means whenever we add 2 elements in the ring, we must get an element that's also in the ring. So we know 3 is in the ring that we want. That means that 3 plus 3 must also be in the ring, so 6 is in the ring. And the question is, can you continue this to generate some more elements in this way? And that's one of the things you're going to do on the in-class activities. We also have to have closure under multiplication. We have that 3 is a ring, that was given. 6 is also in the ring. We discovered that when we added 3 plus 3. And that means that 3 times 6, 18, also has to be in the ring. And as before, I asked, can you generate some more elements in the ring that way? And so I would encourage you to try this with some of the other properties of the ring to see if you can figure out what elements are going to be in the ring. And ultimately, once you think you have all the elements that are in the ring, prove that you have a ring by verifying the axioms of a ring. All right, so what is this going to be in that case? All right, so now we're going to sort of think of constructing rings in the other way. Let's start with a ring, say the integers, and see what happens when you toss in a new element in the ring. Right, so we know that, so we have the integers, and we want to look for a ring that contains the integers, so the integers are going to be a subset of our ring S. So we're going to toss in a random element, square root of 3, that's in S. Specifically, we did it on intentionally not making it an integer so that we get some new elements that we didn't have before. So what else are you going to have in there? Well, we're going to ask many of the same questions that we asked before, right? We know that we have closure under addition. So, for instance, we know 1 is an integer, so that's in our ring. We know square root of 3 is in our ring. We're assuming that. And so that means when we add those two, 1 plus square root of 3, that also has to be in our ring. We have closure under multiplication for the same reasons. 2 is an integer, so that's going to be in our ring. Square root of 3 is in our ring, so when we multiply those, 2 times square root of 3, that's also in our ring. And again, as before, I encourage you to look at some of the other properties to see if you can generate any other elements of the ring. And ultimately, figure out what the entire ring is and see if you can prove that using the axioms of rings. Our next one is Cartesian products. Recall Cartesian products back from our old days in Math 210, or more recently, actually, when we were doing binary operations, we looked at Cartesian products as well. And just to remind you what that definition is, if R and S are sets, the set R cross S is the set of ordered pairs, A comma B, where the first coordinate, the A, is in the ring R, is in the set R, and the second coordinate B is in the set S. And we are going to be looking specifically when R and S are rings. Now, we already have what the elements are, that's just our Cartesian product, but in order to give it a ring structure, we have to define addition and multiplication. So the first thing you're going to have to do is figure out what addition and multiplication is. And to get you started, you're going to assume that 2 elements, say A and C, are in R, 2 other elements, B and D, are in S. how are you going to define the ordered pair AB plus the ordered pair CD? And similarly, how would you define AB times CD? And don't think too hard about it, just use your intuition. What would the most intuitive way to define those things be? And then, of course, you want to see if that makes your Cartesian product a ring. So you're going to want to check all the ring axioms. Our last construction is having to do with matrices. So remember, we encountered matrices back in, Investigation 6 as the n by n matrices with real number entries. Now remember, it has to be n by n, has to have the same number of rows and columns, because otherwise we're going to have some closure issues. So let's see. So the one thing you might notice is that the R, which forms the entries, it is also a ring. So we kind of have two rings going on here with matrices. We have the ring of matrices. The matrices themselves are elements of a ring. But in order to create the matrices, it seems like you kind of need a ring for the entries. So the question you might ask is, what if you made entries of the matrices that came from some other ring besides the real numbers? And if you did that, would the set of matrices still be a ring? Would it still satisfy the ring axioms? All right, so that ought to get you started on what you need for the in-class activities. The in-class activities are on all those types of constructions: finding subsets of a ring, extending a ring to another ring by adding in elements, by looking at the Cartesian products, and by looking at matrices that you get from other rings. The name of the file that you're going to be looking at is Introduction to Constructing Rings, and that is included with this video.